Okay, example 1. Let's remember what we're doing. We're looking at the product of this binomial times this binomial. I'm just going to check my focus and make sure everything's great. Looks pretty good. All right, so what I taught you was in the earlier lesson is that we're going to take this term and we're going to multiply it by each term inside the second binomial. So that's going to be 2x times x. So that'll be 2x times x. Now I'm going to use brackets, and that means 2x times x. And then I'm going to use 2x times 1. Now it's positive 2x, it's a positive 1, so it's a positive 2x times 1. The second step is to take the second term in the first binomial and multiply it by each term in the second binomial. So plus 3 times x is plus 3 times x. Plus 3 times 1 is plus 3 times 1. So now the next step is to do this multiplication. 2 times 1 is 2. X times x is 2x squared. 2 times 1 is 2x. 3 times x is 3x. 3 times 1 is 3. And that's beautiful. We took two binomials, two terms, multiplied by two terms, and we ended up with 4 terms. Now the only difference is we can work with this. Two of these terms are like terms, 2x and 3x. So I have 2x's, 1, 2, plus another 3x's, 4, 5, 1, 2, 3, 4, 5. So I actually have 2x squared plus 5x plus 3. And that's my final answer. So binomial times binomial, you do your arrows. We expand out. I'm going to skip this line from now on and go straight to here. I'm going to go 2x times x is 2x squared. 2x times 1 is 2x. 3 times x is 3x. 3 times 1 is 3. And then I'm going to collect like terms. So this is called simplifying. It's collecting like terms. This is called distributive property. So you distribute using the distributive property. And there you go. That's as hard as this gets. I'm going to pull the camera back a little bit so I have a little bit more writing room. Okay. Something I'd like to throw out here just for a minute. I think it might be worthwhile for us to look at. Let's go back to this original question. 2x plus 3, x plus 1. And let's say the order of multiplication was different. Let's say that it was, instead of this times this, it's now this times this. Now it looks different. It looks like a completely different question. Let's see what happens. X times 2x is 2x squared. Now see this equal sign? This equal sign says that whatever I'm about to write here is equal to what's above it. It's not the same as a left-hand side, right-hand side. It's not an equation. These are equal signs saying that whatever I write is equivalent to what's above it. X times 3. 1 times 2. 1 times 3. Like terms, I've got 3 x's plus 2 more x's. And I do believe we're going to see that those two answers are identical. So the order of multiplication of binomials doesn't matter. That's important to know. I guess the next thing I'd like to sort of look at here is let's go back to the original equation, or question, sorry. And instead of taking the first term and multiplying into the second, is it possible to take this one and multiply backwards this way? So in other words, now it seems a little odd, but this would be x times 2x, which would be 2x squared, x times 3, which would be 3x. I put the second ones underneath so it's easier to see. 1 times 2x is 2x, 3, and we end up with the exact same answer. So even though this seems odd to me, it seems awkward coming backwards, I prefer to go this way, but we're going to get the same answer either way we go. And that is the distributive property. And the order of operation between any two things, as we've been talking about in this course, 3 times 5 is 15, and certainly 5 times 3 is 15. So the order of multiplication doesn't matter. Okay, guys, we're going to stop there and come on back with example 2.